In this video, we're going to learn how to combine logarithms into a single logarithmic expression. We'll use the three logarithmic properties that we've learned from our previous video. Remember that when we have log with any base a of a product of two numbers, x times y, this can be split up as log with base a of x plus log with base a of y. Now what we can do is go backwards. If we have a sum of two logarithms with the same base, then we can combine the logarithms together by multiplying their insides. Next, if we have the log with any base a of a fraction x divided by y, this can be split up as log with base a of x minus log with base a of y. So if we want to go backwards, if we have a difference of two logarithms with the same base, we can combine them together by dividing what's inside. Lastly, if we have log with any base a of some quantity raised to the power of n, this can be rewritten as n times log with base a of that quantity x. So going backwards, if we have any number multiplied inside of the logarithm, that number can be brought inside as an exponent. Let's work through some examples of combining logarithms together using these three log properties. In example A here, we have 3 times log with base 2 of x plus 1 plus 1/2 times log with base 2 of y. So in our previous video, we learned how to split logarithms. Here, when we combine logarithms together, we're essentially doing the reverse. So the first thing we're going to do is take these multiples in front of our logarithms and bring them inside the logarithm as exponents. So bringing the 3 in, we would end up with log with base 2 of x plus 1 cubed. And then we have plus, and bringing the 1/2 in, we have log with base 2 of y to the 1/2 power. Next, we notice that we have a sum of two logarithms, both with base 2. And so we can use our first log property to combine them together into a single logarithm by multiplying their insides. So this leaves me with log with base 2 of x plus 1 cubed, and we're going to multiply it to the inside of our second logarithm, y to the 1/2 power. So we've combined all of our logarithms together into a single logarithm, so this is our final answer. In example 2, we have the natural log of x minus 2 plus 2 times natural log of y minus natural log of x squared minus 4. Remember that the ln stands for natural log, and it just means we're doing logarithm with base e. Now, our log properties work no matter what base we're working with, so it works with base e. The first thing we're going to do is take any multiples in front of the logarithm and bring them inside as exponents. So here we have a 2 multiplied to our second logarithm. We can bring that in as an exponent. So our expression becomes ln of x minus 2 plus ln of y squared, and then minus ln of x squared minus 4. Next, we can start combining our logarithms together. For example, I can combine our first two logarithms together. Since we're adding the two logarithms, we can combine things together using our first property. If we have a sum of two logarithms, we can combine things into a single logarithm by multiplying their insides. So this is going to give us ln of x minus 2 times y squared. And then we still have minus ln of x squared minus 4 at the end. Next, if we want to combine these two logarithms together, we're going to use our second log property because we have a difference of logarithms. When we combine things into a single logarithm, we end up dividing what's inside. So this is going to give us ln of x minus 2 times y squared in the numerator, and since we're subtracting ln of x squared minus 4, the x squared minus 4 goes into the denominator. So we've now combined things into a single logarithm. But for this example, we might notice that we can simplify this even further. One thing that we can do with this x squared minus 4 is we can factor it. It's a difference of squares, so we can factor it as x plus 2 times x minus 2. So let's rewrite our fraction here. We have ln of x minus 2 times y squared divided by x plus 2 times x minus 2. And we notice here that the common factors of x minus 2 can cancel out. So in the end, this simplifies to just ln of y squared divided by x plus 2. And since we can't simplify this any further, this is our final answer. Let's look at one last example. In example C, we have 2 times log of x minus 1/6 times log of z, and then minus 5 times log of y. Now remember that when we have log with no subscript, it means we're working with base 10. So all of these logarithms are logarithms with base 10. So just like before, we're going to take any multiples in front of the logarithms, we're going to bring them in as exponents. So the 2, the 1/6, and the 5 can all be brought inside as exponents. This is going to give us log of x squared minus log of z to the 1/6, and then lastly we have minus log of y to the 5th. Next, we can start combining our logarithms together. Let's combine our first two logarithms together. If we have a difference of logarithms, we can use our second log property, which says that if we want to combine them together, we just have to divide their insides. So this is going to give us log of x squared divided by z to the 1/6, and then we still have minus log of y to the 5th at the end. Next, we can combine these two logarithms together, again, by dividing what's inside. This is going to give us log of, well, our first inside is going to become the numerator, so I'll have x squared over z to the 1/6 in the numerator, and then we're dividing this by y to the 5th. Now, when we have a complex fraction like this, remember, instead of a division, we can think about this as multiplying by the reciprocal. So this can be rewritten as log of our numerator, which is x squared divided by z to the 1/6. And then instead of dividing by y to the 5th, we're going to multiply by its reciprocal, multiply by 1 over y to the 5th. So now we can combine these fractions together by multiplying the numerators together and multiplying the denominators together. This gives us log of x squared in the numerator and z to the 1/6 times y to the 5th in the denominator. So we've now combined all of our logarithms into a single logarithm, and we can't simplify this any further, so this is our final answer. So in this video, we learned how to use our three log properties to combine multiple logarithms into a single logarithmic expression.